Everyone. In this session, we will see about Prim's algorithm. Under this, we will deal with the introduction, concept, example, algorithm, time complexity, and real-time application of Prim's algorithm. Here we go. Introduction to Prim's algorithm. So, a Prim's algorithm is a greedy algorithm that finds a minimum spanning tree for a weighted undirected graph. That is, it finds a subset of edges that forms a tree that includes every vertex where the total weight of all the edges in the tree is minimized. Next, we will see what is a greedy algorithm and a minimum spanning tree. A greedy algorithm is a mathematical process that looks for simple solutions for complex problems by deciding which next step will provide the most obvious benefit. Minimum spanning tree. It is a subset of undirected graph that connects all the vertices together without any cycle with minimum possible total edge weight. Now we will see the steps involved in Prim's algorithm. Step 1. Start any node in the graph. Step 2. Find the edge with the minimum cost in the graph. Step 3. Add the edge found in previous step to the minimum spanning tree. Step 4. Repeat steps 2 and 3 until all nodes in the graph have become reached. Prim's algorithm is best for dense graphs.
Now let us take an example to implement Prim's algorithm. Here in this graph we have vertices A, B, C, D and E. Assume A as initial vertex and assign 0 to it and infinity to all other vertices. With one vertex we cannot calculate distance, so we consider it as null. Check for the direct edge from one vertex to every other vertices. Here B can be reached from A with cost phi, so we have B of A comma phi, and C can be reached from A with cost 7, so we have C of A comma 7. But D cannot be reached directly, so we have D of A comma infinity. But E can be reached from A with cost 2. Now select the one with least cost. We have E of A comma 2. So we write E of A comma 2 here. Now B can be reached from E with cost 3, which is lesser than 5. So we replace B of A comma 5 with B of E comma 3. Similarly, we replace C of A comma 7 with C of E comma 4. D can be reached directly from E with cost 5, so we replace D of A comma infinity with D of E comma 5. Now we select B of E comma 3, which is the least one. E cannot be reached directly from B, so we consider it as null. That is, we consider the same value. The same thing happens for the next one. Leave the node with which has been selected. Now, finally we arrive at the solution where A and E are connected with cost 2, B and E are connected with cost 3, C and D with cost 4, and D and E with. See the algorithm for Prim. The name of the algorithm is Prim with input graph. Assign VT with any one of the vertex in graph and assign null to ET. Let the loop run from 1 to V minus 1. Assign E with minimum weight edge of V comma U, where V is vertex with least cost and U is every other vertices. Now merge the least cost vertex to VT and edge cost to ET as the loop runs. Return ET.
The time complexity of Prim's algorithm is big O of E log B, where E is edge and B is vertex. Real-time application of Prim's algorithm. Minimum spanning tree was first studied for ways to lay out electrical network that minimizes the total cost of the wiring. Other areas of application are computer networking and to generate high-quality mazes.